Hello student, in this video lecture we are going to study the Poisson distribution as a limiting case of negative binomial distribution and recurrence relation between the probabilities of negative binomial distribution. Now first we see the Poisson distribution as a limiting case of negative binomial distribution with parameters k and p. Now first we see if x follows negative binomial distribution with parameters k and p such that k tends to infinity, capital P is equal to Q upon P, this tends to 0 and K into P is equal to M. Here M is the finite constant, M is the finite constant, then the probability distribution of x tends to the Poisson distribution with parameter m, Now we prove this result. This random variable have a negative binomial distribution with parameters k and p, and if k tends to infinity, that is the value of the success is large possible, and p tends to 0, and also m is equal to k into p, m is the finite constant, then the probability distribution of random variable x, that is negative binomial distribution, tends to the Poisson distribution with parameter m. Now proof of this result is this x follows negative binomial distribution with parameters k and p. Okay, then moment generating function of this random variable is, that is mx of t is equal to p raised to k into in bracket 1 minus q into e raised to t bracket raised to minus k. This is the moment generating function of negative binomial distribution. Now this can be written as, which is equal to 1 minus q into e raised to t bracket raised to minus k upon p raised to minus k, again which is equal to 1 minus q into e raised to t upon p bracket complete bracket raised to minus k. Okay, now this can be also written as 1 upon p minus q upon p into e raised to t bracket raised to minus k, which is equal to capital Q minus capital P into e raised to t bracket raised to minus k. Here capital Q is equal to 1 upon p and capital P is equal to Q upon P. Okay, this is the moment generating function of negative binomial distribution. Now this also can be written as mx of t is equal to q minus p plus p, then minus p into e raised to t bracket complete bracket raised to minus k. Means here we subtract p and we add p, so there is no change in the original MGF of the negative binomial distribution. Then we know that this q minus p is equal to 1, so which is equal to q minus p is equal to 1, and from these two terms we take minus p as a common, then 1 minus p into in bracket e raised to t minus 1 bracket complete square bracket complete bracket raised to minus k. Then write down here, since q minus t is equal to 1. Okay, this is the mx of t. Now we take limit on both sides as k tends to infinity. Then we have limit of mx of t as k tends to infinity is equal to, we take limit as k tends to infinity of 1 minus here is p is equal to m upon k into in bracket e raised to t minus 1 bracket complete square bracket complete. In this statement it is given that k into p is equal to m. This implies that this p is equal to m upon k, again which is equal to limit of mx of t as k tends to infinity is equal to limit as k tends to infinity of 1 minus a upon k, here is bracket raised to minus k, this complete bracket raised to minus k. Here a is equal to m into in bracket e raised to t minus 1, this bracket complete, a is equal to this one. Now limit of this quantity is equal to e raised to a. Limit k tends to infinity of 1 minus a upon k bracket raised to minus k, which is equal to e raised to a. Now here we put value of a, which is equal to e raised to m into in bracket e raised to t minus 1. This is the MGF of x, and this is the also MGF of Poisson distribution with parameter m, which is the MGF of which is the moment generating function of Poisson distribution with parameter m. Okay, now by using uniqueness theorem, this X follows Poisson distribution with parameter m. Hence, this result, if X follows negative binomial distribution with parameters k and p, as k tends to infinity and p tends to 0, then the probability distribution of random variable x tends to the Poisson distribution with parameter m. Okay, now we see the recurrence relation between probabilities of negative binomial distribution. Recurrence relation between probabilities of negative binomial distribution with parameters k and p. Okay, if X follows negative binomial distribution with parameters k and p, then probability of x equal to small x, which is equal to x plus k minus 1 cx into p raised to k into q raised to x. Here x takes values 0, 1, 2, dash dash dash, 0 otherwise, and probability of x equal to x plus 1, which is equal to x plus k c x plus 1 into p raised to k into q raised to x plus 1. X takes values 0, 1, 2, 3, so on, 0 otherwise. Now we take ratio of probability of x equal to x plus 1 upon probability of x equal to small x, which is equal to probability of x equal to x plus 1 is equal to this one, that is x plus k c x plus 1 into p raised to k into q raised to x plus 1. This whole divided by probability of x equal to small x, that is x plus k minus 1 c x into p raised to k into q raised to x. Now here p raised to k gets cancelled, q raised to x again gets cancelled, and which is equal to this x plus k cx x plus 1. This can be written as x plus k factorial upon x plus 1 factorial into in bracket x plus k minus x minus 1 factorial into q. This divided by x plus k minus 1 factorial divided by x factorial into in bracket x plus k minus 1 minus x factorial. Okay, this plus x minus x gets cancelled, again here minus x plus x gets cancelled. Okay, then which is equal to, again this can be written as x plus k factorial into x factorial into k minus 1 factorial into q upon x plus 1 factorial into k minus 1 factorial, okay, into x plus k minus 1 factorial. Now we convert this x plus k factorial into x plus k minus 1 factorial and x plus 1 factorial into x factorial as, which is equal to probability of x equal to x plus 1 upon probability of x equal to small x, which is equal to x plus k into, in second bracket, x plus k minus 1 factorial into x factorial into q upon x plus 1 into x factorial into x plus k minus 1 factorial. Now this x factorial gets cancelled, x plus k minus 1 factorial, this gets cancelled, and which is equal to x plus k upon x plus 1 into q. Therefore, probability of x equal to x plus 1, which is equal to x plus k upon x plus 1 into q into probability of x equal to small x. Here x takes value 0, 1, 2, 3, so on. Okay, this is the required recurrence relation between the probabilities of negative binomial distribution, and if the probability of x equal to 0, the probability of x equal to 0 is known, then to compute the further probabilities we can use this above recurrence relation. Using this relation we can easily find out the further probabilities. Thank you.